Hey guys, this is Mrs. Glandry here. I am going to teach you about end behavior of polynomial functions. What you want for today is you want your packet, you want your calculator, and you may use a little bit of scratch paper, but pretty much just your packet and your calculator. You will need that calculator today. So we are going to go over the end behavior of polynomial functions. In order to understand that, we've got some basic understanding that we need to get through. So if we look back at a basic number line, and imagine a number line, so you've got your 0, 1, 2, and then if I go this way, it's -1, -2, whatnot. Now remember, a number line does not have to be centered around 0, so I could have a number line, and let's just say I went with 10. It also doesn't have to go by ones, so I could go to 20, 30, and then if I went this way, since I'm going by tens, I would go 0, -10. So any number line. If you talk about a number line, you have these arrows on the end, and you want to think about, okay, what does that arrow mean? So what this arrow means right here is that as we go this direction, as we keep going this way, this is not saying we're ending anywhere, this is saying as we keep going this way, where are we getting to? Okay, and I'm going 1, 2, 3, 4, 5, 6, 7, 8. Hopefully you guys understand the idea of infinity. We are moving towards infinity. This arrow right here means that we're going towards infinity. Okay, the arrow on the left, on the other hand, means that I'm going -2, then I'm going to go to -3, -4, -5, -6. It's also an infinity, but it's a negative infinity. So this arrow right here stands for the fact that I am moving, and this number line continues on until I get to negative infinity. So we're going to deal with the idea of a infinity, which also can be called a positive infinity. I like to put the positive on just to recognize the difference here, okay? But positive infinity versus negative infinity. Okay, the same thing exists here. Okay, even if I take this -10 off of the board and we're just looking at positive numbers as we go through this stuff, this arrow right here is the highest positive value that you can get to. So we're going to say that that arrow is headed toward positive infinity. This arrow right here, okay, no matter where I started this at, 40, 30, 20, so on and so forth, at some point is going to be the lowest negative value you can possibly think of. Okay, so it's negative infinity. So we have these arrows that represent positive and negative infinity. Okay, now, how does that build into what we're going to do? So we're going to talk about a coordinate plane. Okay, so we should have learned about a coordinate plane quite a bit. If we look at our coordinate grid, okay, we can have points on our coordinate grid, we can have lots of things, but we should recognize that this line, the horizontal line, is the x-axis, and we should recognize that the vertical line is the y-axis. So based on how I drew this, I'm going to talk about this point right here being 0, 0. It's also called the origin, so just a few ideas that are going on there. If I wanted to plot the point, for instance, 2, -3, okay, so I'm thinking about the point 2, -3, I would go 2 in the x direction, 2 positive, and -3, 3 down, because I'm going negative, in the y direction, and I would have a point right here of 2, -3. Right, now all of that is stuff that hopefully we remember, we know. We don't have to worry about in this as much. What we are actually going to be talking about here is called end behavior. So it's at the end of a function. When you are done, when you're at the end of a function, what is the behavior of the function? Okay, it's going to come back to these arrows. So we have 4 arrows on this XY axis, okay, and they're here. And the question is what do these represent? Okay, so right off the bat, if we think about just infinity, okay, I'm going to just do this line right here because that's essentially what we just did. The x-axis is essentially just a number line, okay? As I go this direction, what does this arrow represent? It represents a positive infinity. This is going to be a positive number, the biggest positive number you can think of. Okay, as I go in the x direction this way to the left, I'm getting the biggest negative number you can think of, so the smallest number you can think of. Okay, so that's negative infinity over there. If I look at the y-axis, hopefully you've figured out that we take our number line and we turn it, okay? And for our y-axis, if I'm going up, I'm going positive. So this arrow here is representing my positive infinity, and as I'm going down, I'm going negative. So this arrow here is representing negative infinity. Okay. Now, if we bring all of this together, what we need to realize is that the arrow to the left and the arrow down both say negative infinity, but they do not represent the same thing. The arrow to the right and the arrow up both say positive infinity, but they do not represent the same thing. So how do you tell the difference between those? And it's pretty simple. You come back to these letters right here. Okay, so this is the x in the positive infinity direction. This is the x in the negative infinity direction. This is the y in the negative infinity direction, and this is the y in the positive infinity direction. So we have our x and our y as we're going through this. So I like to keep track of this idea as I go through all of these different ideas, and I like to look at, we've got our little chart, and just say, look at the arrows, okay? And this means as your x value is approaching positive infinity, this means this one means as your x value is approaching negative infinity. Your top one is as your y value is approaching positive infinity, and your last one is as your y value is approaching negative infinity. And so I'm going to hold on to that right there because we are going to use that quite a bit in what we're doing, and you probably want that somewhere on your chart. Okay, so I take out the first sheet of our notes here. And we look at what we have, and I'm looking at this. It says the degree of a polynomial gives us information about its end behavior. So what did we just learn about? We just learned about degree in our last little lesson. Okay, so degree, just as a reminder here as we're going through this, is if I had a function that said x squared plus 3x to the third minus 7x plus 2, okay, the degree of this function is the highest exponent. Okay, so if I look at this, I have an x to the second, I have an x to the third, I have an x, remember there's no exponent there, it's to the first, and there's no x here. So the highest exponent is the 3, that means the degree of that function is a 3. Okay, if the function, and this one's not actually in standard form because I didn't put in the correct order, but we've got the standard form idea. If the function is in factored form, it could look like a lot of different things, but just to give an idea, it could look like something like this. And the degree of that function is a lot harder, so we just have to pay attention as we go. So just as a quick review here, when we're trying to find the degree in factored form, I can't do the highest exponent, so it's not 2, okay? What I have to do is I have to add together the exponents. So what I want to look at is this x has an exponent of 1, this x has an exponent of 1, and then this one's kind of tricky. This one, it looks like for the most part that it has an exponent of 1, but this x is squared, so really it has an exponent of 2 in the end. And so if I go 2 plus 1 plus 1, this degree in that case would be 4. Okay, so back to our notes again, back here with what we're doing. And it says end behavior. So this new term here, and that's the main idea for today, refers to what the graph of a function does as we consider x values close to negative or positive infinity. So we talked about that. So when I look at this, I see x values close to negative infinity. That means I'm thinking left direction. And x values close to positive infinity. That means I'm thinking in the right direction. Okay. The hardest part of this is the notation, which is what you see right here. Okay. On the left side of a graph, what is the end behavior? So every graph goes left to right. Not every graph goes up, not every graph goes down, but every graph goes left to right as we're going through this. And I guess I should clarify every function as we go through this. So as x goes to negative infinity, so this is saying as we go to the left on a graph. So if you take a graph and you look as far left on the graph as you can, okay, what's happening with y? And this is saying y goes to, and then you would have to decide, is it going up or is it going down? Okay, y, remember, is in an up and down direction. Okay, so you're deciding which one of those it is. If it's going up, you're writing positive infinity. If it's going down, you're writing negative infinity. We're not filling this in because we don't have a graph right here. Okay, the right end behavior is written this way. It says as x goes to positive infinity. So this means it's an x value, so x values are left and right. It's a positive infinity, so that means that this is to the right. Okay, it's saying what's y doing. So what you'll have to do is you have to look at your graph and look at the right side of your graph and then see what y is doing. Is y going up or is it going down? Okay, and same as what we saw with our left end behavior. Okay, so that's the introduction to all of this. Okay, there's a lot more coming here as we go through this, but that's just the introduction to end behavior.